So velocity for us is really quite simple. What we're looking for is a flow rate ultimately. We want to find what comes in versus what comes out of a pipe past a constriction, something similar to that. And a lot of times we could also be changing heights. We want to figure out how quickly height is changing. And the formula is part of your RDP packet when you take a certification exam. It's very simple. It consists of a speed or velocity, not to be confused with volume. Be very careful. A distance traveled and the amount of time it takes. So here's what happens. You have the speed or velocity, being speed with a direction, and you say that that is equal to the distance traveled divided by the time. Even though fluid is traveling all at different rates, we use this average speed because, again, we're looking at the larger scale. We're looking at changes in position and changes in height. If you wanted to find time or distance traveled, you actually could do that. There's a nice simple way. I'll show you a triangle that I use to illustrate this. So your speed or velocity goes there, distance traveled goes there, and time goes here. So you could again find the speed by covering this up, and you'd have distance divided by time. You could find the amount of time elapsed by covering this up, and it would be the distance traveled over the speed. Or you could even find the distance traveled, say for instance length of pipe, by multiplying the speed of the fluid and the amount of time it took to make its full trip. Again, most commonly you're going to be using the average speed equation in this form. When you have Q for flow rate, you're taking the velocity, as you see here, and you're multiplying it by the cross-sectional area. So you're literally dragging a volume of fluid, and you're dragging it through that area. So you're dragging that space. It's really area, all added up into some overall volume of water. And so you're saying, how long does it take this slice of fluid to travel from point A to point B? And that would be your flow rate. Simple as that.